Good day everyone, I'm MARIZ DELGADO from BS Civil Engineering 3A, and today I'm going to discuss topic 8 under the surface and subsurface runoff phenomenon, specifically the hydraulics of flow of groundwater. So before anything else, let's first define the groundwater. So groundwater, that's the water found underground in the cracks and spaces in soil, sand, and rocks. It is stored in and moves slowly through geologic formation of soil, sand, and rocks, called the aquifer. So groundwater is widely distributed under the ground and is a replenishable resource unlike other resources on Earth. The problems in groundwater investigation are the zones of occurrence and recharge. So the modern trends are to create more opportunity for recharge of groundwater from natural resources like rain, percolation dams, etc. The advantages of groundwater is that it is free from pollution. The groundwater storage is free from atomic attacks. It can be developed at a small capital cost in least possible time, and it can be used for supplemental irrigation during periods of deficient surface supply. So now let's have the groundwater hydraulics. So groundwater hydraulics covers the flow of water in aquifers and involves the flow and transport processes in porous media. It is concerned with natural and induced movements of water through permeable rock formations. So the groundwater systems vary greatly depending on the geological formation of the aquifer. Now let's have the hydraulic gradient. So groundwater flows from region of higher hydraulic head to regions of lower hydraulic head. The hydraulic gradient is the change in hydraulic head along a groundwater flow path. It has both magnitude and direction. So the hydraulic gradient is simply the change in head from one location to another, which controls the groundwater velocity. So the groundwater flows faster where hydraulic gradient and hydraulic conductivity are larger. So groundwater flows velocities are much slower than the surface water flow velocities due to some parameters, except in limestone cast formation, where groundwater flows through caves and large solution channels. And here is the formula for hydraulic gradient, which is equal to the head 1 minus the head 2 all over the distance between the heads. Now let's have the aquifer. The aquifer is a saturated formation of earth material which is not only stores water but yields it in sufficient quantity. Thus, an aquifer transmits water relatively easily due to its high permeability. Unconsolidated deposits of sand and gravel form good aquifers. Aquifer consists of two types, including the unconfined and the confined aquifer. So let's have first the unconfined aquifer. So unconfined aquifer is also known as the water table aquifer. So as you can see here in the picture, this is the water table aquifer. For the hydraulic head and hydraulic gradient in unconfined aquifer, the hydraulic head is equal to the weight of the water above it. Next is the confined aquifer. It is also known as the artesian aquifer. It is an aquifer that is confined between the previous beds. So as you can see here, confined or artesian aquifer is located here where the drill holes end is located, and it is above the aqueduct bedrock. For the hydraulic head and hydraulic gradient of confined aquifer, the hydraulic head is measured by drilling holes into the ground and measuring the level to which water fills the hole. And the hydraulic head of confined aquifer is shown here in this picture, where there's a drill hole 1 and drill hole 2, and this is the direction of the flow path, which comes from the higher region head to the lower region head, since it is caused by the gravity. That's all for today's presentation. Thank you so much and have a great day.